Hey everybody, it's chemistry time. You're here with Miss Gray and with Whitney.
Hi.
So we're going to show you how to balance chemical equations, and I bet you've done this before, like in middle school?
Mm-hmm.
Yeah? Good. Well, I'm going to show you some tricks and techniques. Wow, for balancing equations. So first, let's look at how molecules are symbolized in an equation. One way is to show a molecule. So if there's a subscript in the middle, then that means it's just telling us how many kinds of atoms are all stuck together. Like Cl2 is 2 chlorine atoms stuck together. But if I write it this way with a 2 in front, then that just means 2 chlorine atoms that are not together. They don't hang out as a group. Right, they're separate. That's what not together is, yeah. That was the word I needed. Well, now if we have 2 chlorine molecules, that's like 2 groups of chlorines. Mm-hmm. How many atoms is that of chlorine?
2.
2 in each molecule. And so, since there's 2 molecules, that's 4 atoms altogether.
4 total.
Right. Okay, so here's what we know. Sometimes a molecule has parentheses, especially if we have polyatomic ions. And so the parentheses just tells us the number of atoms inside. So when we have parentheses times 2, then everything inside here gets multiplied by 2. So this is a skill that we worked on in Unit 5, remember? Mm-hmm. Counting atoms, that hasn't changed. So here's a molecule for calcium hydroxide where we have 1 calcium, just like in the formula, 1 calcium, and then I have a hydroxide over here and a hydroxide over here. Does that make sense? Mm-hmm. Great. Moving on. The OH is a group and it stays together. The 2 refers to both of the O and the H. I have scribbles. Clear that writing. Okay, so let's count atoms. How many sodiums are here?
1.
Okay, how many oxygens?
1.
Good. And hydrogens?
1.
You like it when I ask you easy questions. Mm-hmm. Yeah, me too. Okay, calcium. We just did this one. How many calciums?
There's 1 calcium.
Okay, how many oxygens?
But there's 2 oxygen and 2 hydrogen.
Right, so that's a total of 5. Okay, now let's make it tricky. If there's 5 atoms in this molecule and I have 3 molecules, then what do I do?
You just multiply to get 15.
Yeah, because it's like 3 groups of 5. Mm-hmm. Yeah, and that's multiplication. Well, that wasn't so bad. I said it would be tricky, but I was just teasing. Now let's balance equations using the same idea, because the law of conservation of mass states that matter cannot be created, nor can it be destroyed. So that means when we write a chemical equation, we have to make sure that we have the same number of atoms on either side. So we're going to be able to rearrange the atoms in a chemical reaction, but we can't get rid of them, have them disappear or appear out of nowhere. So for any particular atom, the number has to be the same on both sides of a reaction. And by sides, we mean, all right, here's the arrow, and we have reactants, can't speak, and products. These are the 2 sides of a chemical equation.
And the arrow means yield, right?
Yeah, exactly.
So it's kind of like an equal sign.
Yeah, it's like an equal sign, but equals means they're the same. In a reaction, in order for a reaction to take place, they're not exactly the same anymore. Mm-hmm. Like this one. We saw this one in class. It was kind of fun. We put a strip of magnesium into a fire and we burned it. And that was the one where the flame was so bright you had to look away or it could blind you. So I remember that. You?
Mm-hmm. Yeah.
Yeah. And we know that magnesium was silver and shiny and flexible, and magnesium oxide was white and powdery and brittle. Mm-hmm. So it's definitely not the same after the reaction. Let's look at what's happening with the atoms. Okay, so I have an atom of magnesium, and I have a molecule of oxygen that's made from 2 atoms of oxygen. And what it made after the reaction was a molecule of magnesium oxide. Remember, magnesium forms the 2+ kind of ion, and oxygen makes the 2- ion. So to make a molecule, I just get 1 of each atom, and it works. Okay, but here's our problem. This isn't balanced. Do you see why?
Yes, because you have 2 oxygens on the left side and only 1 on the right side.
Exactly. So we're going to have to fix that. So let's count some atoms. I have 1 magnesium, and 2 oxygens. And then here, let me label these, magnesium and oxygen. And then here I have 1 magnesium and 1 oxygen. So I have to fix oxygen. Since I have 2 here, let's put a 2 out in front. All right?
Okay.
But when I do that, it changes what magnesium is. It changes both of these to 2. Just like when we had 3 calcium hydroxides. Now we have 2 groups of magnesium oxides. So I have to come back to this side and fix it so it works. Now
so you can just put a 2 in front of that.
Yeah, exactly. So that's our balanced equation. That, what we just did, is called balancing by inspection. So we started with our skeleton equation. Your book calls these skeleton equations because it just includes the formulas without balancing. And then we balanced it. So we had 2 magnesiums plus 1 molecule of oxygen makes 2 molecules of magnesium oxide. So that one is the way we write it. Let me show you a way we don't write it. We could have solved the problem by putting 1/2 in front of the oxygen, but we can't put fractions in a balanced equation, right? That would be like having half of a person.
Right.
Yeah, it's possible, but it's just not right.
Mm-hmm.
Yeah. Okay, then what if I put a subscript down here? Is that allowed?
No, you can't add subscripts.
Exactly. We can put coefficients out in front, but we can't change numbers back here because that changes the identity of the substance. Okay, how about this one? What if I had 4 magnesiums, 2 oxygen molecules, and then 4 magnesium oxides?
It's not correct because you can reduce it.
Right. This is not in simplest terms. We would have to divide this whole thing by 2, and then it would be right. I think that's all the different ways to write it that would be wrong. Yeah. I'm sure somebody's going to make one of those mistakes, and I'll get to say, I told you so. But that's okay. It's a learning experience. Okay, here's some hints. Start with elements that occur in only 1 compound on each side. That will help you balance it more easily. And the other hint is to treat a polyatomic ion as if it was a single entity, especially if they repeat. A polyatomic ion that shows up on both sides of the equation is acting just like a single particle. So we'll see some examples of that. So we're going to use inspection here. You ready for some math?
Yes.
Oh, good. All right. So phosphorus looks like it's just fine.
Mm-hmm.
We're going to have to find out what number to multiply oxygen by so we can add up to 10.
Well, 10 divided by 2 is 5.
Okay. So we can just put a 5 there.
Mm-hmm.
That was easy. Let's try this one. I'm going to write water as HOH instead of H2O because look, here's my OH right over here. So that helps me keep track of where the OH went.
Mm-hmm.
Okay, here's where my hydrogen is. And now I have 2 hydrogens. So I want to put a 2 here so I can have 2 hydrogens.
Okay.
Now I have 2 OHs. So I'm going to put a 2. And we'll come back. There we go.
But now you have 2 lithium.
Okay,
So you have
let's
to put
fix
a 2
that.
in front on the other side.
Okay, so now here's my concern. We put all these 2s. Do we have something that we can reduce? Look, we have a 2 and a 2, and then here, oh, that's just a 1.
Mm-hmm.
So we can't reduce it. It is in simplest terms. We've got it balanced now. That worked. All right, I'm going to circle nitrate because this is my polyatomic ion. We want to keep it together. It's a family. You can't break apart my family. That would be mean. All right, I have 3 nitrates and only 1 nitrate. So let's try putting a 3 out front. Okay, what else changed when I put a 3 there?
Now you have 3 potassiums.
Okay, so let's come back here. Oh, I have a 2 there. So if I put a 3 here, that makes 6 potassiums. All right, well, we'll have 6 potassiums. Now what? Now I have 6 nitrates.
Now you have more nitrates on one side.
That's okay, because look, 3 goes into 6 2 times. So we'll put a 2 there, and that fixed bismuth.
Mm-hmm.
And look, sulfur is 3. Good thing we had a 3 here, because sulfur now is all fixed too. So balancing by inspection is just going back and forth until you get them all the same. Let's do one more. I wanted to make sure we did an oxidation one.
Okay.
Because in these ones where we're adding oxygen to something, it's easiest to save the oxygen for last. So let's count carbons.
You have 1 carbon but 2 atoms of it.
Right, okay, so I'm going to put a 2 in front of the carbon dioxide on the other side so that carbon is fixed. Now don't worry about oxygen yet, let's just fix the hydrogen.
You should put a 3 in front of the hydrogen on the right side.
Okay, so now I have 3 waters, so let's add up the oxygen. I have 4 here because 2 times 2 is 4. Then I have 3 here for a total of 7. So if I had 7 halves, then I could balance this.
No, you can't use fractions.
All right. Well, since I can't use fractions because Whitney won't let me, then I'm just going to double everything so I can still use my fraction because I still want 7 halves. But if I double everything, then that gets rid of
The
this.
fractions on the bottom.
Right. So now I have 2 of these and 7, and then this got multiplied by 2, and then this got multiplied by 2. So that's how we handle these reactions that are called combustion reactions. When we're burning something, oxygen gets added, and to make oxygen work, if you use a fraction, no big deal, just multiply by that denominator, and it all gets fixed.
Okay.
All right. Let's try another method because that one got really complicated. I think
Good idea.
I think it might be better if we use a table for big reactions like that where we have to keep track of a lot of stuff. So under my equation, under my skeleton equation, I'm just going to make a table.
Okay.
All right, let's count how many magnesiums are on the left.
There's 1 magnesium on
Okay.
the left.
And on the right?
1.
How about hydrogen?
1.
And over here?
There is 2.
Okay, 2 of them on the right. And chlorine?
Only 1 on this side
And-
and 2 on the other side.
Okay, good. Well, I see where we're going. We're going to have to fix hydrogen. And hydrogen's right here, so I need a number here that works for hydrogen, and I'm going to put a 2.
Okay.
Okay, when I do that, that multiplies hydrogen by 2, so that's fixed. But it also multiplied chlorine by 2, and so now that one's fixed as well. So our balanced equation is just right here.
So
With
you
it-
fixed it.
Yeah,
All done.
right. And the table helped us keep track of it, so we made sure we were doing it right. Not every equation is going to need a table, but if you're not sure or it's not working, you could give that a try. So here's a few where we could try a table.
Okay.
So I need to list my atoms, calcium and nitrogen. So on the left I have 1 calcium and 2 nitrogens. You want to do the right side?
On the right side, there's 3 calciums and 2 nitrogens.
Okay, well nitrogen is all good to go. It's the calcium that's the problem. So what should we multiply 1 by so that it's equal to 3?
3.
Okay, we're done. That was easy. Great, let's do another one. I'm going to clear this writing so we can see what we're doing. Oh, this is a lot of stuff to keep track of. So let's see. I'm going to just write bismuth in the middle. Then I don't have to keep writing chlorine, hydrogen, sulfur. Will that help us keep track?
Yeah.
Okay. Sometimes this is called an atom inventory because like an accountant would have to do an inventory and count all the cans on the shelf, right, and pennies and all that. Okay, 1 bismuth, 3 chlorines, 2 hydrogens, 1 sulfur. My side's done.
Okay. On my side, there's 2,
Okay.
and then 1, and 1,
All right.
and then 3.
Wow, everything's a mess.
Nothing's balanced.
Nothing is balanced. But whatever we do for chlorine has to work for hydrogen. Okay, so I'm going to use that for a clue because I have 3 chlorines and 2 hydrogens. So we'll probably have to add up to 6. Does that make sense? So let's just start with that. We're going to multiply this by 6. And what do I multiply this by?
2.
Okay, so the 2 is going to go in front of bismuth, and that changed bismuth, and now bismuth is fixed. Now let's fix the hydrogen. What do I multiply hydrogen by to get 6?
3.
3. So the 3 goes in front of the thing with hydrogen in it, and that changed sulfur at the same time. So that's fixed. Now we got everything done all at once. That was pretty slick. Okay, we have one more like this, and it's a combustion one, just like the last one we did. I'm not gonna make a table. Yeah, we're gonna leave the oxygens. So let's fix carbon. We got 4, and hydrogen. So now I need 5 waters, right? Okay, well let's add up our oxygens.
You have 8 oxygens.
Okay, and the carbon dioxide.
And then you have another oxygen, so you have a total of 9.
I have 5 though.
Oh, 5,
Yeah.
right, because you multiplied.
Right. So that's 13. And so I want to put 13 halves, but Whitney won't let me use fractions.
So we have to multiply the whole entire equation by 2.
Okay, so I'm just going to rewrite it. So I have 2 of the C4H10. That name is butane for that molecule. Then 13 oxygens. Multiply 4 times 2 is 8. So we have to multiply everything, not just the first piece, and then 10 waters. So this reaction describes what happens in the little candle lighters that we use in class to light the Bunsen burners with. Yep, when we make a fire there, that's the reaction that's going on.
Cool. Oh, very cool.
Yeah. Well, that wasn't too hard to balance.
No, that was pretty easy.
Okay. Let's see another method, because look at all the junk in this equation we'd have to keep track of.
Right.
Yeah, this can get complicated pretty quickly. So I'm going to show you what's called the matrix method. Have you seen that movie, The Matrix?
No, I haven't.
Oh, it's so cool. All right, so we know we want to find some number that goes out here, but I don't know what the number is. So like in algebra, we use letters to stand in for numbers we don't know yet. So I'm just going to assign letters to the unknown coefficients.
Okay.
Okay? So there it is. There's my letters. My next step is to make a grid so that we can keep track of each element or ion in the equation. So see how phosphate is still phosphate over here? It doesn't break apart. Then I don't have to count phosphorus and oxygen separately. I can just count how many phosphates there are. Okay, so I'm going to keep track of calcium and a phosphate, then hydrogen, and sulfate stays together, so I can keep track of that separately too.
Okay.
All right, and that would be all the things I need to keep track of. Okay, so look in my A term. How many calciums are in the A term?
3.
Okay, so I can write 3A, like that. Now look at the B term. How many calciums are in the B term?
There aren't any.
Right, so I'll put 0 times B for now. And the sum of the atoms on the left have to equal the sum of the atoms on the right. So I use an equal sign. How many calciums are in my C term?
1.
So I put 1C.
And there's not any in the D.
Okay, I'm going to go ahead and put a 0D. But this is not how we normally write an algebraic equation, because the zeros we wouldn't normally put in there. So let's simplify this. It would be 3A plus nothing. So equals 3A equals C. So I just can leave those out. All right, well that's one equation. Let's do another. Let's do the phosphate equation. How many phosphates are in my A term?
1.
There's 1 in the parentheses, but there's that 2 there.
Okay, yeah.
Right, since I circled it, it was hard to see that. So 2A, how many in the B term?
None.
None. How about in the C term? Do I have any there?
No.
Okay, so 0 in the C. Now my D term is over here.
We only have 1.
Right. There's no parentheses there. So let's reduce this equation. I'm going to get rid of the zeros so that it looks more manageable. Because 2A equal to D, that seems a lot easier than the rest of all that mess. Okay, hydrogen. I don't see any hydrogens in my A term, is that right?
Right.
Okay, how many in the B term?
2.
All right. C?
There aren't any.
None. Okay, and in the D term?
There's 3.
3 in the D. Okay, so I get 2B equals 3 times D. All right, next is sulfate. 0 of those in the A term.
In the B term, there's 1.
Okay, how about in the C term?
1 also.
All right,
and there's none in the D.
Okay, well this is an easy equation then. I just get B equals C.
Mhm.
All right. And here's all my work. We're going to need more space here. Okay, so then our third step was to reduce each equation.
So we already have that done.
Yeah, that part's done. And so now I'm going to solve for the coefficients. I'm going to try and figure out a number for A and a number for B and C and all that other stuff. Well, in algebra you would use substitution and adding equations. We're not going to go to that much headaches. We're just going to say A is 1.
Okay.
Okay? And so if A is 1 and C in my first equation is equal to 3 times A, then 3 times 1
It's just 3.
is 3. Well, that was easy. And we also know by our equations that B is equal to C. So B is 3 because they're the same. And then how do we solve for D? Looks like this equation will get us there or this equation. Do you care which one we use?
We can do the first one.
It looks easier, huh?
Yeah.
Okay, I have 2A equals D, so 2 times 1 equals D. D is 2.
Mhm.
All right, well, what does that mean? We go back to our equation and put these numbers in. We put those numbers A, B, C, D.
Mhm.
So let me get rid of all this writing mess. So now we write the equation. So see for A, we said A is 1,
Mhm.
B was 3, C was also 3, and then D was 2.
Perfect.
Yeah, so once you solve for your variables, you just put them right back into your equation.
That's easy.
Yeah, remember when we had a fraction in the combustion reaction?
Mhm.
No big deal. If you get fractions in this kind of matrix balancing, just multiply the whole thing by the least common denominator.
Okay.
Yeah, and then you won't have fractions anymore because that's not allowed.
Mhm.
And that's how we balance equations. So guess what you're going to have in your warm-up?
Balancing equations.
Balancing equations. You got it. And that's it. We're done. So see you guys.
Bye.